Alright, this video is going to help you understand how to use exponent properties. And at first, I'm just going to show you where a few of the properties come from before we practice doing a couple of larger problems where you might mix a few of the properties together. So the first thing we want to understand is algebra can be a long and tedious task if you really break it down to its basics, such as if I want to multiply x squared times x cubed, you might say that that's x times x being x squared times another 3x's for x cubed, which means grand total, if you lay it all out, writing them all out that way, you've got x to the fifth power. Or you could do the same thing for this quotient property over here. You got an x times an x over x times x times x. And again, it gets to be writing out a lot. What if these exponents weren't 2's and 3's? What if they were 5's and 7's and 12's? Well, you can still use this idea because now I can cancel a couple of x's each, and notice that I'm just left with this x on the bottom. Remember, if there's nothing on top, there's also a 1, so your final answer would be 1 over x. But a better idea, rather than working that out the long way, is to take advantage of some exponent properties. Knowing that if you have the equal bases, notice a to the m and a to the n, that you can add your exponents, we can quickly just say, well, this is x to the 2 plus 3, which essentially becomes that same x to the fifth that we got before. And along those same lines, if a to the m divided by a to the n, again, equal bases, so I can subtract my exponents, works out, then we can say x to the 2 minus 3, and that becomes x to the negative 1. Later on, we'll also get the exponent property that negative exponents make fractions, and that x to the negative 1 is 1 over x. We'll mention that again in a little bit. A couple other exponent properties. The power of a product property says that two things multiplied to the same power can be sort of separated. So if I wanted to simplify, get rid of the parentheses, simplifying always asks us to do that. This statement here, I can say that this is really 3 to the fourth times x to the fourth, and now I could actually work with the numbers. 3 to the fourth is 81. 3 times 3 is 9, times another 3 is 27, times 3 is 81, and x to the fourth. But notice I no longer have those parentheses on there. It can also be a different way to reduce fractions. Power of a quotient property gives me a great way to say, okay, maybe I don't want to divide 64 by 16. They're pretty big numbers, but I recognize that 64 is actually 4 to the third, and 16 is really 4 squared. Well, that means that I can say 4 to the 3 minus 2 is really just 4 to the first, and this quotient is really just equal to 4. Again, another great way to use those properties. The final property, or I guess third to last property, but the last big property we're going to learn is called the power to a power property. And x to the third squared is a demonstration of having a to a power and that whole quantity to another power. And in that case, essentially, again, if you wrote it out the long way, that's x times x times x times another 3x's because we're squaring it, right? The squared says this happens twice, and inside the parentheses we have 3x's each. Well, basically that just becomes x to the sixth power. Instead of doing this the long way, again, we can just multiply. This becomes x to the 3 times 2, which basically, again, is x to the sixth power. Gives you a nice shortcut for power to a power. That's the one that you're probably going to want to know the name of, versus all these other properties, such as the negative exponent property that we just talked about a minute ago. A to the negative m equals 1 over a to the m. You can flip that over. By the way, that also works backwards. If you had a to a negative exponent on the bottom, that just becomes a positive exponent on the top. So that also works. And then the last property to definitely know of is called the zero exponent property. Anything to the 0 power equals 1. So that's our big list of all of those properties. Again, if you're going to know the names of any of them, I would know the name of power to a power property. The other names aren't as important as knowing how to use them, but power to a power we will refer to every now and then. So on these next pages, I just have a few pages of examples for you. So if you take a second, write these down, see if you can't use some of the properties to help you simplify these different statements, such as multiplying inside parentheses. How can I deal with this 2 exponent on the outside? Go ahead and pause the video now, try them out, and then I will lay out the answers for you in just a second. All right, on the screen I've got the answers for you to both of the problems. The first thing I did was looked and said, well, hey, I've got two things multiplied inside the parentheses. So I separated them both to become squared using that power of a product property. Now, -4 squared, don't forget to also square the negative, use those parentheses, but that can become 16. Then 2 to the third to the second is a power to a power property, so that's 2 to the sixth. I just multiply the exponents. And I also noticed that, well, 16 times 2 to the 6th doesn't seem very familiar, or doesn't seem very easy to do, but 16 is actually 2 to the 4th. If I can get equal bases, remember equal bases multiplied, I can add my exponents. So 2 to the 4th times 2 to the 6th is really 2 to the 10th. And written as an exponent, that's a great way to simplify your problem. If you actually want to solve or evaluate the problem, you can make that into 1024 or 1024, which is equivalent to 2 to the 10th. Along those same lines, there's a lot of ways you can kind of begin this one. We could have actually brought that -1 into the top, into the bottom using the quotient. But I noticed again I had equal bases, 11 to the 5th over 11 to the 8th. So I went ahead and used my subtraction property here, quotient property, saying that 11 to the 5 minus 8 becomes 11 to the -3. And now power to a power can make that into 11 to the +3. And at that point, the only thing left to do is evaluate. 11 to the third is 1,331. Again, just two good ideas of how you can use lots of properties to hopefully simplify. I didn't have to touch a calculator until the very end when I was finding those larger powers or powers of a larger number. But I can at least simplify down and make it one thing to type. Go ahead and attempt these three as well, again, just using those exponent properties. All right. Here are these three worked out for you. Again, you're just multiplying with equal bases. So all I did was added all my exponents, -4 plus 6 plus 7, and you get b to the 9th power left over. For that second property, again, first thing I noticed, I don't have equal bases this time, but again, I've got two different things being divided to the power. So I just took the top to the -3 and the bottom, s cubed, to the -3. Power to a power says -2 times -3 is r to the 6th. And 3 times -3 becomes s to the -9th. But remember, negative exponents, we don't want those left in our final answer. So a negative exponent on the bottom of a fraction can be moved to the top, leaving nothing behind. So think of this as being over 1. Well, we don't need to write that part into our final problem. So we leave r to the 6th on top, and s to the 9th moves to the top, and we're left with just r to the 6th, s to the 9th. On the bottom here, very last problem, again, separate the parts that are alike. 16 over 2 is just the numerical part of the expression. Then you've got m to the 4th over m squared, so I can use my quotient property again to subtract the exponents. And the same thing with the n's. N to the -5, n to the -5 becomes n to the -5 minus -5, so think of that as +5, and -5 plus 5 becomes 0. 16 over 2 was 8. We got m squared, n to the 0, and remember, anything to the 0 power is technically equal to 1, so therefore this really just becomes 8m squared times 1, or 8m squared. Finally, just the last one I've got for you here is a way that you can use this, or these exponent properties, kind of in the real world, or in the science class at least, where you might use scientific notation. So let's set up what we have, and then we'll see how scientific notation can help us out at least a little bit. A swarm of locusts can contain as many as 85 million locusts. We'll realize that 85 million has a lot of zeros in it. So if we remember to science class and say, well, scientific notation tells me I can move my decimal 1, 2, 3, 4, 5, 6, 7 times and make this really into 8.5 times 10 to the 7th. And that's 85 million locusts per square kilometer. They can cover an area of 1,200 square kilometers. Okay? One swarm can cover that area. What we want to know is about how many locusts are in such a swarm. Well, if they can cover 85 million locusts per square kilometer, right? And they can cover 1,200, right? Or 1.2 times 10 to the third, right, square kilometers. Well, if we took 8.5 times 10 to the 7th and multiplied, notice if I multiply kilometers squared times locus divided by kilometers squared, my kilometers squared are just going to cancel away. So I'm going to multiply these two numbers together, 1.2 times 10 to the third, and that should leave me with just how many locusts I have. Well, tricky part is we need to multiply 8.5 times 1.2, and there's really no shortcut for that. But secondary, we can do 10 to the 7th times 10 to the third, and I can at least shortcut that and say, okay, well that's 10 to the 10th, and 8.5 times 1.2 will give me an answer of 10.2. And if we move our scientific notation a little bit more, one more decimal place, so that becomes 10, or sorry, becomes 1.02 times 10 to the 11th. Again, we're just moving our decimal one more spot, so we add one more to our exponent. Or if you think about it, that's really 1.02 times 10 times another 10 to the 10th, right? Still over here. Well, add your exponents again, you got 10 to the 11th, and you've got 1.02 times 10 to the 11th locusts. Or you could move your decimal places there. Remember that 6 became a million, 9 would be a billion, and so 11 is basically 102 billion locusts. That's a lot of locusts. Anyway, I hope that helps you with exponent properties, and have a great day.